So I'm going to have you do this again silently and independently. We're going to kind of treat it like a practice for our quiz without consulting each other and see what we can come up with. Israel, here. Felix, Edith, Eli, Dahlia, Stephanie, Diego, Jamie Lynn, Sandy, Brandon, here. Brian, here. Juan Carlos, Martin, Nan, Kennedy, Giselle, she's not here. Caesar, or Leo, here. Gustavo, Lirio, Tyler, Melanie, Lazaro, Jonathan, Messiah, Joanna, here. Kevin, here. Eham, Christina, Johnny, here. Luis, here. D'Anthea, here. Brian. Here. All right, silently, you've got left 3 minutes. So again, treating this like a quiz, even if you don't know the answer then, circle something, Brian, Joanna, circle something. Treating it like a quiz that you would have as your answer. We're going to see how many you get out of 3 as like a practice for that. This is the you don't know. Yeah, that's good. Any more bomb vents over here? If you didn't turn in your pump set right now, no worries. You got till the end of the day to get it in that inbox. Or this one will be on my cart. If you can find me running around the school, then you can turn it straight into the cart. So either works. More seconds to commit to an answer for each of these so we can see how many out of 3 you would get. 50 seconds. Sorry, we're just going 50 seconds. A few more. 20 seconds. Coming to an answer. Alrighty, let's see what we came up with. Hopefully this will kind of give you an idea about how you feel looking at some multiple choice as we go into getting closer to our first quiz. I'm going to kind of talk about the calendar in a second. But let's talk right now about this first problem. So we're going to actually work This is resting just perfect. Be careful. Is that better? Okay. Here, actually, I'll just do this. Oh. Okay. Let's work backwards. So raise your hand for participation points if you can give me an answer to eliminate. Oh. Messiah, give me one. How do you know you can eliminate E?
Well, I the biggest exponent, and I found that it's an odd positive.
Okay, so he said odd positive, and so he knew that was wrong direction. Another one to eliminate, Brian?
B.
B, because again, if it's odd positive, that would be even positive, okay? So eliminate that one. So now we're down to 2. So we're at the end. I'm not going to be able to. We're not going to be able to tell which of these. So now who can tell me which one they eliminated and what was their final answer, Dahlia?
I eliminated A because turning point is 4 and this is 9.
Okay. What we have to be careful of, so that's a good kind of hint to something that we're thinking about. But technically, remember, it wasn't the exact number of turning points. It was the most number of turning points. So if this has turning points 2 and this has turning points 4, both of those are less than 4 or equal to 4, right? That 4 is the most, and both of them have less than 4 or equal to 4. So either could still work, but you're on the right track, okay? So either one could kind of still work, but D is correct, so you're there. We got to kind of think about why else. Any other thoughts about why? Kennedy, other thoughts?
I don't think this is right, but I looked at the negative 8x cubed, and I thought that if it was negative, it would go over to the right instead of to the left, like the A did. That's probably
Interesting. Okay, so there might be some patterns with that, with some of the positive negatives doing other things on the positive and negative side. Okay, so let's think. These points, okay, if I give you a graph, these points, what do we call them again?
Zeros.
Zeros. They are roots or zeros, but zeros, I like that title for them because that means these numbers should literally make my equation equal to what? 0. So both of them have -2. Both of them have 0. So when I plug in those values, I should get 0 because they're in both graphs. What's the only one that this one has, that one doesn't? Positive 2. So I should be able to plug in 2 right here and get 0 if that's a root. And I know it's like maybe you might need your calculator, or you could use my handy dandy poster. 2 to the 5th is 32 minus 8 times 2 cubed is 8 plus 16 times 2, and you should end up getting 0 for that as well, and know that 2 and -2 then have to be zeros, okay? So there's some kind of patterns there. What we're going to be learning today, woohoo, is I wrote here can't factor. That's because up until this point, we don't have a tool. It's not that it can't be factored, it's that we don't have a tool to be able to factor it, like our box for a quadratic, right? Today, we're going to be learning some tools for how to divide polynomials and therefore factor something like this, so that when you got to a problem like this, you could either plug in 2 or you could do something else to check whether 2 was a factor or not, okay? So we're going to kind of build some skills to get better at this, but a lot of us were kind of at least able to be 50-50, right? And eliminate a lot of the answer choices with the stuff that we learned last week. Okay, on to the back. Let's talk range and roots really quickly. Can I get one volunteer for the top one who feels like they might have that one for a stamp? Yeah?
okay.
A is correct. Range, -infinity. There's a break right here at -2. And then it picks up again, -2 to infinity above -2. Okay, last one. Let's talk about radicals, about roots. Any takers on that one? Ehong, what'd you get? G. G is correct. Let's talk about it. if we break these up, root 36, root x 16th, root y to the 20th, maybe that'll help us out. The square root of 36 is 6, so we know it's going to be one of these, okay? If we talk about this, we're not just going to take the square root of 16. Remember we said we could rewrite this as x to the 8th squared, because 8 times 2 is 16. And this is y to the 10th squared, because 10 times 2 is 16. And your squared and your square root will cancel and leave behind the x to the 8th and the y to the 10th. Yep. Okay. Are we okay with that?
Yep.
Okay. So you can't just take the square root of these, like, or something like that. Or plus the square root of 20 is not even 10, so. Yeah?
What would be wrong with doing like x to the power 4 times?
You do x to the power 4 times x to the power 4, like that. You can do that, but a fourth and a square root won't cancel each other and leave you with 4, right? A square and a square root cancel each other. A 4 and a fourth root would cancel, but it's not a fourth root. Cool? Okay, so good practice with these. On your quiz on Wednesday, we have our first little mini quiz. So it'll be a shortened version of even like the quiz you saw in Unit 1. It's going to be 5 quick multiple choice and then a little like 1 question basic skills and free response. Few things that are going to be on that to look out for. Definitely the graphing polynomials with the roots, okay? So go back and rework some of those problems, or tomorrow I'll be giving you back your problem set so you can look them over. Definitely will be at least 1 regression problem, what we did on Friday. So you need to know the steps in your calculator. During a quiz, it is not considered an instruction question to ask me where to go on your calculator to do a regression. That's part of the skill of knowing how to run a regression, is knowing where to go in your calculator. So you need to troubleshoot all the calculator stuff yourself. I can't answer those questions in the quiz. So please also review those steps and those menus in your calculator and let me know if you have questions, okay? Other than that, we also did solving radicals. So like squaring both sides to cancel them and things like that. And so that'll be on Wednesday. And I'll have your problem set back to you tomorrow for you to look things over, okay? Today you got a new problem set because you don't have school Friday or Monday. Hey, you. It will obviously not be due on Monday because you won't be here. So I will expect that from you first thing when you get back on the 10th. Well, you have till the end of the day. Same thing. But on the 10th, by the end of the day, I'll need problem set 2 from you. As a note with problem sets, a lot of y'all did a really great job on this one, starting early and asking me questions. However, I still know there's a lot of people saving the majority of it till the weekend, which is your call, right? Like I'm giving it, it's on y'all to figure out how you want to pace it. But I mean, I'm having a lot of people that I think are showing up on Monday with majority of the problem set still not completed, trying to just like finish up and like gather answers on Monday. One, your problem set's going to be a little bit like sloppier in terms of mistakes and like maybe not getting all the questions. You might run out of time, so your score will probably be lower. 2, I've had a lot of great questions and people reaching out to me at lunch today, which I'm there to do. But on Monday, know that there's probably going to be a lot of other people that show up with questions. So if you're there expecting to ask me like 10 questions or 10 problems, I might not have time to answer all your questions. I'm going to try my best. But if other people are there, I got to kind of like split my time, okay? So email me questions over the weekend. I had some people that did that. Or just start tonight on those problems so that you can ask me kind of piece by piece throughout the week, okay? If you take a look at this problem set, I don't want you obviously working on it in class, but I'll kind of show you really quick. Because this week we have a quiz and no school Friday, we really only have 3 lessons and they're actually pretty tied together. So I went ahead and I made the front page instead of all new stuff. This is review. So you could actually knock that out tonight if you want as you're studying for your quiz Wednesday. Okay. Page 2 is what you could also complete tonight based off what we do in class today. We're going to be dividing polynomials, and so you should be able to get started on this stuff and knock out a lot of your problem set tonight. Please start early. Okay. Last thing about the calendar. if you take a look, next week there has been a change because your PSAT, if you're in 11th grade, is on Wednesday. 9th, 10th, and 11th, I think, are taking that. And 12th graders, that means they're going to have something else I think y'all are going to be doing. So we'll run like an alternate schedule and all that fun stuff on Wednesday. So I won't see you in pre-cal class.
What's it called?
On alternate schedule?
Oh, analysis?
Analysis?
Say something.
I said something, probably.
I think we're good.
I say a lot of things.
Yeah, I think we're good. So we come back.
So Thursday, so then on Thursday, let's talk Thursday. Thursday is the college fair, which means we miss like part of the day we're here, all that weird stuff. So I cannot teach a lesson because like half my classes I see and half I don't, and then they would all be like different timing. So if you see me on Thursday, we will I'll just grab some review problems and we'll work on your problem set and answer questions. We'll do it kind of like pre-cal tutorials, but still pre-cal focused. But I'm not going to go on to new material until I have all my classes, which will be on Friday. Okay? So that's a heads up with that. Because of that change, it did push back my unit exam one day. So if you look at your regular original calendar, if you want to make that change, if you have it written down, your Unit 2 exam will now be on Friday the 20th rather than the 19th. And we'll start the new unit the next week. Okay?
Yeah.
Alright. Keep an eye out for all that stuff. Let's divide. Polynomials! Wiki, wiki, wiki. Make sure everyone's with me. Okay, cool. Polynomials. Let's take a look. Voices up. I want to make sure we can get through everything today. Let's just re-ground ourselves in division in general. So eyes up here, Brandon, you with me? We don't need that for right now. Perfect. In general, something to note, because we kind of lose this when we get into polynomial land, is if you have something divided by something, 6 divided by 2 is 3, right?
Yep.
Then you can take your quotient and multiply it times what you divided by and get back to your original starting number, right? That's like a fact family of multiplication and division go back to back, okay? So we are going to be using division to divide, but we're also going to be using division to find ways to factor polynomials and rewrite things as two polynomials multiplied together equaling another polynomial. So take a look. If I have this polynomial, today we're going to be able to divide it by something like x minus 3, and it's going to give us some new polynomial q of x, like maybe x squared plus something, 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 okay? That q of x times what we divided by, x minus 3, will be equal to the polynomial we started with, and will be a way for us to factor, right? I can find our zeros of a polynomial, right? Cool. Okay, so let's jump in and see what we've got. This first box right here basically is explaining kind of what I was just showing right here. It says consider the polynomial function f of x, this big long polynomial, I'm not going to read it. If you know that f of x has a 0 at x minus 3, then you also know x minus 3 is a factor, right? If x equals 3 is a 0, that came from x minus 3 being a factor, right? Okay? Because f of x is a third degree, the highest exponent, we call that the degree, is 3. You know there exists a second degree polynomial. This would be like x squared something, something, something. That can be multiplied to form f of x. Remember leading term test? We said x squared and x would give us our x cubed. Okay? Alright. This implies that q of x can be found by dividing our polynomial by x minus 3 because the quotient is equal to that function divided by x minus 3. So here's that relationship I just showed you up here. These two things you can either multiply together to get your function, or you can write it as division to get your quotient. That's like a fact family, you go back and forth. Okay? So the question becomes, how do I divide something that looks like this? I know 6 divided by 2 is 3, but how do I know what polynomial q of x I'm going to get over here? some of you might have done last year long division with polynomials.
Yeah.
Okay, a few people that might sound familiar. And if you want to use that as a tool, like I know Sydney in the last class liked long division, and so she was working long division, and as long as she was getting the same answer as us, I was like, you're good if you like that strategy. This year, I'm going to teach you another strategy that I don't think many of you have seen, that I like because it's a little quicker and I think efficient. So it's similar to long division. It's a process called synthetic division. It's just a way we're going to organize our work to divide polynomials and get to our quotient polynomial, I think, a little bit quicker possibly than with your long division. But you're obviously still, like I said, able to use that as a strategy if you like it. But I'm not going to explain long division as much yet. Okay, so here we go. Synthetic division is just a shortcut for dividing a polynomial by a linear factor of the form x minus c. Like x minus 3 is in that form, right? X minus a number. So we're going to be dividing by things like that. So I'm going to model right here our steps to do that, because it's kind of funky. Seems kind of like magic. But what we're really doing is honestly things very similar to long division, but we're doing it kind of shorthand. We're going to actually chop off all the x's and not deal with them until the end. We're just going to deal with the numbers. Okay? So in order to keep our work organized, we're going to kind of put always a box and a line, and I'm going to tell you kind of what we're going to write different places. So we're going to start with that. In this box or little half box right here, we are going to put the 0 of what we are dividing by, the binomial that we're dividing by. So if I'm dividing by x minus 3, what is the 0 or the root of that? 3. So I'm going to put, some of y'all always say, the opposite of it, but it's the 0 of right here. If you want to even, label that in your notes, 0 of that guy, so you don't forget later when you're looking, where did that 3 come from? We're going to put the 0 of our binomial right there. Okay. Up here next to it, in a line, we're going to put the coefficients of our different terms right here. And we're going to make sure that if we're starting with x cubed, we have to make sure that we go in order, like x cubed, x squared, x, and then x to the 0. And if one is missing, we have to account for that and put that there's not a coefficient, basically, and put 0. Okay, so let's go in order. If I have 6x cubed, I'm just going to write the 6. I'm going to chop off the x's for right now. So I've got 6. My next coefficient, this goes down by 1, so I'm good. I got x squared. I'm going to write minus 25, 18, and 9. So x cubed, x squared, x, and this is x to the 0 power if there's no x there. Okay? And I'm going to leave a little space right here. We're going to be writing some things right here, okay? All right. Here's how this is going to work. The kind of efficient trick to synthetic to remember is that we're going to be always taking a number and multiplying it times our 0 over here, and then we're going to be adding these columns, the number with the number below. To start off with, there's nothing below 6 right here, right? So we're just going to, if you're not adding anything to 6, it's just 6. Again, you're just going to bring down that first number always to start off with. So just start with 6 right here at the bottom because that's our first number. We're going to take 6 and we're going to multiply it times our 0. 6 times 3 is? That's what we're going to write in this first spot under negative 25. And then we're going to, like I said, add the columns. So we're going to do negative 25 now plus 18 will give us negative 7. Cool. Now we're back to multiplying. And negative 7, I would write this as we're going so that these numbers magically later, you don't just write down and don't know where they came from. Make sure, with me, you got it. Negative 7 times 3 is? That's what we're going to write next, negative 21. Now add it up. Negative 3. Now negative 3 times 3 is negative 9. Add it up. And we have 0. This last number is going to be your remainder. And so if we got 0, that means it went in evenly. X minus 3 is a factor. It went in evenly. And this is our quotient, and we have 0 remaining. These numbers are not like our answer, so we can't just stop here. This is just a tool to find our quotient. These numbers represent the coefficients, just like these were coefficients, right? Of our quotient, which is like our answer to a division problem, right? Quotient polynomial. Because if we dividing polynomials, our answer is not going to be one number, it's going to be a polynomial. Okay, let's think about it. If I take something cubed, I'm just going to pretend for right now it's a monomial. If I take something cubed and I divide it by something to the first power, x to the first power, what happens with these exponents again? So this is now going to be something squared, right? It like knocks it down by a power. So the same thing is going to happen here. When I divide it by x minus 3, these are the coefficients of my new polynomial, but my new polynomial is no longer going to be something cubed. It's going to be now 6x squared minus 7x minus 3. So this first degree, like the leading term or the highest degree, is now going to go down by 1. It was cubed before, now it's going to be squared. 6x squared minus 7x minus 3. So our quotient is 6x squared minus 7x minus 3. It's a polynomial. That's q of x, our quotient polynomial. And our remainder is 0, so it went in evenly. We're going to see some today that are going to have remainders of actual numbers. So if I just ask you to divide, this is going to be your answer. Later towards the end of class, I'm going to ask you to factor it, and we're going to use this quotient like for a purpose. Right now I'm just asking you to just divide and give me the quotient. Okay? Question? Yeah. In general, when I'm dividing by a power of x, it's no longer going to still be x cubed because I like took out a power of x when I divided. Okay? So for example, like if I just do a monomial divided by x, it's now going to be x squared, right? Like it's going to knock it down by power. Or something like interesting is, remember we got this relationship that if I divide, this times this should be equal to this. And when I multiply, these two should add to this one. So this times what we divided by, 5 and an x squared, that now multiplied is going to give me my x cubed back. Okay, cool. Alright, so that's my quotient and that's my remainder. If you go ahead and look on the top of the next page, we're going to practice this. And we're going to look right here at 3 kind of like different cases. I'm going to kind of release you to practice, but we're going to sort of stick together. I'd love for you to just practice. But we got to cover some other cases of what happens when there is a remainder and some things like that, okay? For this first one, when we set it up with our little half box in our line, can someone remind me, raise your hand. You're good. And be careful, be careful. Can someone remind me what we put right here to start off with? Sandy?
The 0.
The 0 of what the binomial we're dividing by. So what's the 0 of x plus 2? Minus 2 or negative 2. Good. Cool? So it's not just the 2, it's what makes it equal to 0. So negative 2. And then we're going to write our coefficients. So 2, raise your hand if you can tell me what is going to go next, and be careful. Trick question. D'Anthea? Oh, so close. Not quite. Not quite. So let's talk about it. Remember, I like picked on you. Sorry, it's a trick question. Remember, they have to go in order. So if I start with x to the 4th, this next one should be representing x cubed. And is it negative 5x cubed?
No.
So if that one's missing, we have to literally say that there's actually 0x cubed if it's not there, right? So that's why this one's kind of different, and I wanted to, before I release you, point that out. You got to put a 0 placeholder there for the x cubed. Now, the answer says minus 5. She was correct.
Yeah.
Then 5, and then minus 2. So I've got the 4th power, the 3rd, the 2nd, the 1st, and the 0 power of x at the end. Okay? All right. Now that we have that, we're going to bring down our 2, and I'm going to let you go ahead and try your synthetic division, multiplying and then adding your columns. See if you can use the example we did to figure this one out. Good, so now add 0 plus -4 is, you write that down here. And then now multiply -4 times -2 is positive 8. Good, write that, now add. Then multiply and add. Multiply and add. Positive 3, good, now multiply again. Nice, nice. Alright, out your answer. Oh, thank you, sir. Alright, oh, no, changed his mind. How you doing, Juan?
Okay, you're right there, you're right.
Adding, multiplying, all the things. Good. Oh, so when you multiply, this is great, but you write it right underneath the 0 and then you add them. So put it here too. -4. And then you add it and got -4. So -4 times -2 is 8. So put that there and that now. Good. This is
I just thought that times -2.
-2. No. Oh, this is a -2.
Yeah, and that's
Oh, okay. I'm gonna quickly, as you're finishing up, if you haven't yet, jot down what I got, and you can check and make sure none of your numbers got off, but I saw good things as I went. Okay. Gustavo, is that my final answer though? Do I just leave that?
Yeah.
No! Don't do it. I had people doing that last year, and we've got to make sure we're like conceptually understanding what's going on here. Like synthetic is a tool to divide polynomials, so my answer is not just like these 4 random numbers and a 0. My answer is a polynomial. Raise your hand for a participation stamp if you can give me my resulting polynomial from my division. Johnny, go for it.
2x cubed minus 4x squared plus 3x minus
2. Here's my quotient, and my remainder was what? 0. 0, so that's why there wasn't anything there at the end. So that means our remainder is 0. Okay. For the next one, I'm going to let you set it up and do it. Just as a check, as you're going, don't freak out. The numbers are going to get slightly bigger, so like, but don't be like, ooh, these are big numbers. They're fine. And at the end, you will not get a remainder of 0, so we're going to come back and talk about what to do with that remainder other than 0. Okay? Try it. Go for it. No, whichever one it starts with, the highest. So like 3 is the highest, so you're going to start with 4, and then now you got to start counting down and make sure we don't miss any. Does that make sense? So like it doesn't need a 4th power and a 5th power, like whatever it starts, the highest. Now just make sure there's no misses. 3, 2, 0. Only who use hand, right?
No, I don't want to.
Here you go.
3.
So now we're going to talk about what to do with the remainder. So just hang tight, you're good. Check his when he gets there, and then we're going to talk about how you write the remainder. Yes? Yep. No add. You add the columns, multiply it. Good, now add. Good, now multiply. No, ignore this. This always times, you're always multiplying times this number over here in the box. So now ignore this, now we're on 15, 15 times 3 is going to give us the next one. 45? That's 25 times 3.
What is it plus back now?
15 times 3, I think it's 45. And then, yep, and then add.
44.
Good. Then multiply.
48 times 44.
Yep, then add. Cool, good. You can write starting your quotient polynomial, but then we'll talk about what to do with the remainder. So your quotient will start the same. 4x squared
Oh, it's fair.
plus, like that'll start the same, but then we'll have to talk about what to do with the little 140 at the end. Good, I'm seeing good things, so we're gonna bring it back in a second, because I think most people have the numbers that I want to see. Very good, very good. Okay. Okay, if you want to check your numbers, I'm not going to walk through the entire synthetic, but you should have ended up with something that looks like this, okay? So if you are listing it, stick with me people, this is the new stuff. If you are listing this out, we would say the quotient still comes from the part before the last. So this is still going to give us the coefficients of our quotient. And then it would be 4x squared plus 15x plus 44, right? That's still the coefficients of our quotient. And this 140 is our remainder. However, you will not typically be able to leave it like that. You're going to have to write this in a special way where we like incorporate our remainder. Let me show you what I mean in terms of bringing you back just to the days of good old dividing. So you're in elementary school, the good old days, you got recess, you got all the things, maybe you even have nap time. Anyone ever have nap time in school when they were really little? Yeah, think all that. Okay, think of the good old days and watch me really quick. I want to connect this back. Watch it. If I were to do something like 6 divided by 2, that's just equal to 3. Your remainder we say is 0 because it goes in evenly 3 times, right? If I do something like 7 divided by 2, though, you say 2 goes into 7 3 times. That gives you 6. And you subtract, and 1 is your remainder. And you might have started in elementary school. You wrote like a little like remainder 1. Okay. So anyways, then you get to me in 6th grade. Back when I used to teach 6th grade. And I broke those little 5th graders' hearts, and I told them you can no longer write the little remainder 1 because that means something, and we have to write what it means, okay? And so then we got to the point where you had to either write that remainder as like a remaining piece, as like a fraction or a decimal, okay? So we're going to be kind of writing ours as like fractions, so I'm going to show you how we did it with a fraction. If you remember to write this remainder 1 as a fraction, you took it and that meant you had 1 piece left out of, we were splitting this into like groups of 2. So this was like, it went in 3.5 times because we had 3 full times that went into 7. And then 1 out of 2 like pieces that were left, and you wrote it as like a little fraction like that. Your remainder became the numerator and your denominator was the number you were dividing by, okay? So what we're going to do is we are going to write, stick with me, okay, we're all back. We're going to write our remainder as a fraction, what they're going to call a rational function. So they'll say in the instructions almost the same thing as like, can't just use like remainder 140. Like we just did the same thing. We just said remainder 140. We want to write it as a rational function. So we're going to write our quotient just like we wrote the 3, right? 3.5. We're going to write our quotient. This is the equivalent to the 3. Plus, kind of like we've just got plus this extra half, we're going to have plus our rational function for our remainder is going to be the remainder number of pieces, which is what? 140 out of what we divided by, which is x minus 3. It's that entire, we divided not by a number, we divided by a binomial x minus 3. I know in ours we used the 0 to do that, but we didn't divide by 3, we divided by x minus 3, that binomial. Okay? So this is what you will need to write if you get a remainder and it asks you to write your quotient as a sum of the quotient polynomial and a rational function. That's what it's looking for, okay? So remainder 0, remainder non-zero. Technically, I could write this as 0 over x plus 2, right? But 0 over anything is 0, and so we don't write it as a rational function. We don't have to. Okay? Alright, yep.
So is that just our whole answer?
Yes. So this is all cool and all, but this is kind of like back in the day when we were like, remainder 1. We don't want to just write that. We want to like write it as a rational function. Cool. Last kind of different thing to clarify, and then we're going to talk about writing our answers as factors. Take a look at this next one. Raise your hand for a participation point if you can tell me what looks different about this last one on here. Eham?
Equation is more complex.
Yeah, the equation that we're like dividing by, this is not now a binomial, it's a quadratic, it's like a polynomial, right? So we've got x squared minus 4x minus 12, okay? So let's think about how to handle this. If I start setting up my synthetic, I'm like, I don't know really what to do, but I guess I'll just start drawing my box. So let's draw our box. I'm trying to figure out what goes in here, and I'm kind of stuck because I can't see this, but does anyone have any ideas? Like thinking about what I said we should be putting here, what are we looking for to go in that box again, Kennedy? The zeros, which is, it doesn't look like this, so we can't just be like -2. But, do we know how to find zeros of a polynomial that looks like this? We can do our box to find our, we're actually going to have 2 of these, and then we'll have 2 little zeros, okay? So, take a second. I'm going to go give out my stamps. You guys do your box. Rapid fire, you got 1 minute, do your box. We always box in. Why are we doing that? Dos. Yeah, you just asked me about your, you have to write it like that. Raise your hand, who's got it? We're going quick. So we make sure we get to the end of the lesson. Lyra's got it, everyone else, voices off. Everyone else, voice off.
-6 and
X plus 2, x minus 6 is what she got as an equivalent. That's still the same function, but in factored form, right? Okay, so if you see something like this, yep, Melanie? That's factored. So now for your zeros, correct. What are our zeros? They would be -2 and 6 would make this equal to 0. Okay, so we have 2 of them, which means when we're doing synthetic division, to divide by this entire polynomial, I actually have to divide by both of these. I'm going to have like a 2-part box, which is why we're like really good and quick at box, because now we would have to divide twice, but it still shouldn't take very much time. It's kind of like, technically, you might not have ever thought about this, but if I'm dividing something by 12, technically I could break up 12, still with me, Daniel? I could break up 12 into 3 times 4, right? I could, you can try it, like if you're dividing something by 12, that you'll get the same answer as if you divide that thing by 3 and then divide by 4. Like you can always split up division like that if you want, okay? So what I'm going to do is I'm going to divide by this factor, and then I'm going to take my answer, and I'm going to divide by this factor. It actually does not matter though which one we do first. You could start with the 6 or you could start with the -2. You should get to the same answer, okay? Stephanie, which one do you want to start with? -2 or 6? She says let's start with 6. So we're going to start with 6. We're going to go through this instead of you doing it on your own. For the sake of time, I'm going to kind of push us all together on this one so that I can get to my last point. So I got 1, -3, -36, 68, 240. There's no zeros in there because there were no missing terms. Bring down your 1. Let's run through this quickly. 6 times 1 is 6. 6 plus negative 3 is 3. 3 times 6 is 18. 18 plus negative 36 is negative 18. I know that because I did this problem 3 or 4 times already today. Negative 18 times 6. I'm also a genius, could do that in my head. Negative 108. That was me calculating. Negative 108 plus 68. I think I remember. 40. Negative 40. Someone check me if I don't remember these. Negative 40 times 6 is negative 240. And that gives me 0. Which means it has a 0 remainder. It went in evenly. Okay. Part 2. Because I just divided by this one, right? But in order to divide by the whole thing, I would have to divide by both. I don't want to like restart and divide my beginning. I want to take what I have now, which is technically 1x to the third plus 3x squared, right, if I were to write it out. I want to take that new polynomial and divide it now by x plus 2. So you could rewrite it, or if since you've already got them written down here, just like add a new line. I'm trying to keep it neat, but I'm running out of space, so sorry if you are too. I'm going to bring down my 1 and just do it one more time. Negative 2 times 1 is negative 2. That'll give me 1. 1 times negative 2 is negative 2. Negative 2 and negative 18 is negative 20, which gives us positive 40 and 0. So I end up with 1, 1, negative 20. I know it's far down there at the bottom, so one more time I got 1, 1, negative 20. Which means, if this was x to the fourth, the first time I divided, it knocked it down to x cubed, or x to the third power. The second time I divided, now it's x squared. So I have 1x squared plus 1x, or x, yep, I don't need the ones, right? Minus 20 is my quotient, and my remainder is 0. Lazaro just came in and he's like, what? But I'll get you there. Yep.
What about the x to the power 4? Why is there no x to the power 4?
Okay, so one more time. First time I divided, I got 1x cubed. I divided again, now it's 1x squared. Cool? Because I divided twice, so it went down twice. Okay? Okay, quick thought in here. I did not get to the bottom 2, which are now switching gears to factoring using your quotient. So tomorrow what we're going to pick up with is, now I have my quotient. I've got cube x. How do I rewrite it back in factored form? So use my quotient as like a tool to do something in math, okay? So come practice up on this tomorrow. We're going to use it to actually find factored form. Me too. Pick up this. Then I gotta open the
I'm reading.